a minute. I have to do that and that. And that should do it. Okay, and then I have to mute everybody. And then I have to turn down my sound or they will drive us nuts, which is here. All right, anyway, so what happened is, just like City College, if you had a game and it was really just one product running on one device, it might be secure. But what happens is, if you use it for years, you have sprawl. All these other parts of your network grow. And so what these guys had is other domain names that they were not using anymore, but were still connected to the product in minor ways. So they found, the main thing is, I guess, Epic Games, there's something called 2004 stats.epicgames.com, which is something that was supposed to be important in 2004, but they didn't take it down. It's still up. So they found that this old forgotten domain had a cross-site scripting vulnerability. So you could redirect traffic from that domain to go to another. And the problem is, it's in the epicgames.com top-level domain. So this website has access to all the cookies. So if there's a cross-site scripting vulnerability, you can send a URL to someone, and when they click on it, they go to this domain, and it takes their cookie and sends it to a third party, so you get their authentication cookie. And that's what this attack is. We'll be doing a lot of this in the web application hacking class this semester. Unfortunately, this is how the web works. There's no HTTP, has no authentication, no session control, so your identity is typically in a cookie, and typically the cookies are not very well designed, so if you steal a cookie, you can reuse it in another machine at another time. That's not necessary, but people don't often remember to put in controls for that. So in fact, the cookie is just sort of like an ID card or a password, and it turns out to be pretty easy to make a mistake that will leak out the cookie, and then people can totally get in. And of course, these things, the games are the virtual currency, like before there was Bitcoin. You could buy magic items in a game, and they're worth real money. So getting in people's accounts and stealing their stuff is actually as good as stealing a bank account. Even though it's technically fake money, it does convert to real money. So anyway, so it's pretty important. Yeah?
Quick question. It's still fake, right? Because it's virtual?
Well, what happens, it's same with World of Warcraft. You can get stuff by playing the game and winning it, or you can go to a forum and buy stuff. And then your character has stuff. And other people can steal it from you, and they can then sell it for real money. That's why they have gold farmers. In World of Warcraft, there's a bunch of people that just play the game to make money. They do something to earn like a minor magic item, which they then sell for money. So, I mean, you can get real money out of it, but it's kind of screwy.
Sorry,
that's all right, yeah.
I still remember years ago, people played Warcraft and
yeah.
like $300-400 off that one account.
Absolutely. I mean, World of Warcraft accounts at one time were considered more valuable than bank accounts or credit card accounts because they're easier to turn into money, and you actually end up getting more money. So, I mean, it's the same thing would be true of things like loyalty cards. They're not officially money, but they can be converted to money, so stealing them would benefit you. Anyway, so let me get down to the official stuff. We're on track here. All right, and I'm going to do this mute again, and send me a chat message if I forget to mute people and someone's barking dog is irritating you, which tends to happen to the poor online connectors. So everything you need for this class is on my website, samsclass.info. If you've taken my classes before, everything is pretty much the same. There's only a few small changes. I did get a new textbook, and we'll have some new lectures and projects in here, but more about that soon. But anyway, we're going to study mobile devices, primarily Android applications. That is the main vulnerable thing. iOS has gotten very secure and very hard to audit. It's gotten so secure you can't even get in the testing tools. So we're going to do a little bit of iOS, but not much. It's mostly going to be Android, which is a sitting duck. So we'll talk about how to secure mobile devices and how to hack into them primarily through applications. And so the quizzes are online in a Canvas system. This is much simpler and easier than it was last semester. I got better at using Canvas, so I took away most of the nonsense we aren't using. The only thing in Canvas is the quizzes and your grades. That's it. And you don't have to get an email to enroll or anything. You just click this link and join. Anybody can join. You do not need to be a college student here or anything. You will only get City College credit if you actually manage to add the course, which God have mercy on you, because the system here is broken like it's been for years. So where even if you have an add code, it's very difficult to add. But if you don't want to go through all that because you don't really care about the college credit, you can totally participate. And I did get some art over the break, so I will issue badges. People have said I should make my own badges, so I'm going to do that. I don't know if anybody cares, But anyway, I'll issue those. You'll get something from me to say you finished the class, whatever that might mean. But anyway, if you are officially enrolled, then of course you get official college credit. And so the quizzes are here, and then there's a lot of homework to do. You can watch this. You do not need to come to class. You don't get points by being here, and you don't lose points by not being here. You can watch a live stream on Zoom, or you can watch a YouTube video later. Or you can just ignore all that and read the book. If you find a lecture useless, all these are fine. All I care is that you learn it. And typically, only about half the students come after the first few weeks because, you know, they're busy and it's a commute and everything. I mean, I hope you find some value in coming, but if you don't, that's up to you. And so I have the first quiz due next week, but I'm not going to punish you until after the ad code. So you don't lose points for being late up to, I think, 2/6. But I recommend doing it because you should read the chapter and take the quiz before you lecture on the chapter. That's better if people have been through it once. The only point of the quiz is to encourage you to study the chapter. So you have 10 minutes. You can take it twice. Obviously, I have no control. You can be looking up answers on Google or in the textbook, and really that's okay. The point is just to make you study. So most people score high on the quizzes, and that's fine. It just means you've been through them. All this class is just a game. I used to do game design long ago. This is just a way to trick you into studying. So the quizzes trick you into reading the book once or twice. The lecture tricks you into somehow hearing it all again. And then the homework tricks you into doing it again. It's just a way of tricking you into doing what you need to do to learn. That's all it is. Anyway, so there's a lot of homework. Most of this stuff comes in by email. A few of them come in by automatically going right into Canvas. The star ones are going to automatically go into Canvas. Most of them are coming in by email still, because I've been excited by other shiny objects and I haven't been motivated to go back to the old projects and upgrade them to the API, which was my original plan, but big things changed over the summer. And we're going to talk about these projects. I switched to a new textbook because we're going to use a much more powerful Android auditing system than I used to use. And this homework I'm going to demonstrate tonight, Project 9, that is a 0-day that came out today at 1 p.m. And it affects 100 million Android users. Well, I say, when we get there, we'll talk about it. I would expect some people in this room are vulnerable to that right now. How many people have Android phones? That's what I thought. 4 or 5 of you, it's reasonably likely that at least one of you is running this app. And you're probably going to take it off when you do this homework. Anyway, because it's a really popular app. I've run it a lot. And it's amazing how bad it is. And that is the big lesson here. Anyway, so I use simulated ones. I had an Android phone, the very first one. The very first Android phone was bloody awesome. If you sent an SMS message, every SMS message was executed as root in the command shell as a bash line. It was just awesome. And they have continued to be that outrageously insecure. I mean, they fixed things, but somehow they're still amazingly broken. Anyway, so all I wanted to do tonight is give about mobile device security in a general level by talking about a few motivational things I presented at DEF CON. And then we'll start covering the textbook and such next week. And then I want to demonstrate some of these projects. So how many people need ad codes? Okay, I'll just do that later, maybe after the lecture. I'll bring them up, because I think you'll find you have to wait about a week to use them anyway. Unless you use paper, people tell me they're having very little luck actually adding classes with the online system, which is extra messed up. Yeah. Yeah. Yes, everybody is. The online portal doesn't seem to work very well. Some students tell me they succeed by taking a real physical piece of paper in, and other people tell me they succeed by just being very patient. But realistically, I think you might just have to wait a week or two. You have until, I think, the 4th of February to add. So hopefully it's enough time for them to fix the system. We will see. Last semester, I had 36 students try to add, and only 6 of them ever really got in. So the systems here are often so broken that you never do get in. But anyway, if you really need the credits, then you really have to navigate this system. And I was talking before class, that's a useful social engineering exercise. Can you actually succeed in navigating your way through the city college bureaucracy? If you can, that will be valuable on the job. When you try to get a raise or do anything else, on the job, you'll have another broken bureaucracy to cope with, and learning how to handle them is a valuable skill. Anyway.
The best thing to do is print out the error code before, like a couple of days before the deadline, so they know you made an attempt and you had an error code, and they can't really complain if you try to do it legitimately and it's late.
You can try it. You're right. I do recommend in general keeping a copy of everything and planning to have a lawsuit. That is the right attitude to have. Have evidence. I've reversed a few of the most appalling things here by having proof to prove that they had to change things. That sometimes helps, but it doesn't help as much as you think it would. Anyway, so I would like to play these slides if I can figure out how to operate my computer. All right, it's not playing for me. All right, it's doing all sorts of stupid things instead. All right, just a minute. Keynote, play. Yeah, it's diagonal crooked thing. Option Command P. Okay, Option Command P. There we are. All right. So I hate these symbols. I can never figure out what they are. There used to be this thing called English, but anyway. So all right. So this is me. I teach here. I'm on Twitter, which is the best way to reach me. Email is touch and go. That's why there's a special email address for everything to do with if you're turning in homework or anything that affects your grade. Please email the official class website. Email, which is here, cnit.128sam@gmail, because that goes into responsible hands of my grader. Email that comes to my personal account often gets lost and buried under horrible things, and I sometimes don't see it. So this is where anything directly related to the class ought to go. Then it will actually be handled by someone more responsible than me. All right. Anyway, so all right. So let's talk about problems with mobile devices. One huge problem is persistent login. The fundamental problem with mobile devices is the whole reason people use smartphones is for convenience. It's great. Now the phone goes ping, you look, you've got an email, you know, instead of having to wait until tomorrow when you supposedly log into your heavy desktop machine and see if you've read your emails, you find out right away. But it has to mean everything has to fit on that little portable device, and you can't type very well on that little portable device, so they can't really expect you to keep putting your password in frequently. So you have to log in once and stay logged in essentially forever. So the app has to somehow remember who you are. And the app is running on a very rudimentary device without much power. And so there's various ways to do it. Now, let me just see if I'm going to start with the other one first and come back to this one because I think it might be an introduction. So let's start with this one. So you have mobile apps. And we're going to go through this in quite a lot of detail in the class, but there's a lot of vulnerabilities apps have, and there's OWASP, the open source project that rates the vulnerabilities of web applications and mobile applications, and they have listed the top 10 vulnerabilities. And this is the most common vulnerability, although they consider it the least secure of the top 10, which is insecure lack of binary protections. If you have a normal Windows app, like Microsoft Word, they wrote it in a language like C++, they compiled it, and they gave you the compiled version, which is now assembly code or machine language, and it's very hard for you to reverse engineer it and alter it. It is possible, but it really is quite an advanced job. Very few people know how to do it. So people pretty much have to use it the way it's written, and they don't modify it. The problem is it is very easy to modify Android apps because they do not get delivered that way, and most developers do not know this. They think when they give you an app, you can't open it and mess with it, but you can. It is extremely easy to open and mess with it because Android apps run in Java. And the whole point of Java, which is what Java, how many people have written Java? Use Java? A few. Java is super important in the world. It is very, very frustrating to use for everyone. It's very hard to install on a machine. It frequently crashes. The path is wrong. It is very hard to program. It crashes a lot. It runs slow. But the huge advantage is you can write something in Java and it will run on every platform, on Macs, on the PC, on servers, because it's running in a Java virtual machine, which is like a little virtual machine. It's not really running on the base hardware. It's running in a virtual machine that's run on each app. So that makes it buggier and slower, but it means it runs on every platform. And that saves you so much time with your developers. You do not have to have a team of Android developers and a separate team of iOS developers. You just write stuff in Java. So almost everything on the phone runs in Java. And Java, when it's compiled, does not compile down to machine code. It compiles down to bytecode, which is run in the Java virtual machine. And the bytecode is only a little bit more complicated than Java itself. So you can totally read that bytecode and modify it. So Android is number one. It's not this drastic anymore. I've got a more, you'll see next week, I've got a more modern switch. Now it's more like 55% Android and 45% iPhone. But at this time it was 80% Android. So apps have to be signed. Now code signing is intended to mean you can't modify an app. That is the main control. You're supposed to have an app. This is true if you download a Microsoft update or anything else, then you have a signature. And when you run it, it's supposed to verify the signature. And if the signature doesn't match, it won't run. But Google Play totally does not support this, and Android doesn't enforce it. You can sign it with an unofficial signature that is not backed up by a real certificate, and it will not complain. So it is kind of pointless. And the Android debug bridge is the main tool. We're going to use it all the time. You turn on debugging mode on your phone, and then you connect with a USB cable, and we're going to use virtual ones. And then you can totally issue this ADB command from the operating system or another device connected, and you can totally control the phone through the command line that way. You can push apps on it, pull apps off, go on the file system, enter a shell, examine the data, and that's what you typically do when you're developing on a phone. Most commercial devices don't ship with ADB debugging turned on, and you'd only do it for development. But it's very good for us if you want to audit what's happening on the phone. So you can push something to the phone, pull it, you can view the log to see what's happening on the phone, install things, and you can have a shell, just a command line shell on the device. So here's what happens if you do analysis. In normal Windows binaries, static analysis is very painful. You have to use things like IDA Pro. You see this long line of assembly code that is pretty dense and frustrating, and it is considered a big barrier to people getting in. But static analysis is actually fun and easy on Android. And this is why. So here, for example, is, so if you want to get an app off the phone, all you have to do is pull it with ADB pull, and then unpack it with the free tool APK tool, because the APK file is stored on the phone, the original installer, and that is just a zip container that contains all the code to run the phone, to run the app. So here's TD Ameritrade. When you unpack it, you see a bunch of folders. Here's the TD Ameritrade folder. Here's the mobile. Here's the API. And these have really handy names like account manager, consumer, real obvious names that guide you through it. Bank of America is supposedly more secure. They use the ProGuard free obfuscator. What ProGuard does is it changes some of these things to like A, B, and C, but it doesn't change very many of them. A bunch of them remain: deposits, locations, and here's one called business credit card details activity. The one that's handling a secret, it's not obfuscated. So ProGuard is completely worthless. It's like having a guard that will lock half the doors in the building and go home. It doesn't stop anybody. It doesn't even make it, doesn't even slow you down. I don't know why they bother. And so here's the Java that the developers saw. They had to write this perform login, and down here they had parameters put username and parameters put password. And here's the code right from the app off the phone. It looks this different. Method, perform login, param p1 username, param 4 password. This is not much harder to read than that. And that's what I mean. Developers don't understand. I have your source code. I can totally read your source code. I can just look for the string password or credit card number, and it's right there. So it's not, and the developers typically do not understand this. They think of the world of Windows, where it is not true. A compiled Windows app, you can't easily do this, but you can totally do it on Android. So you can just sign the app, make a modified version, push it back on the phone and run it. And then you can do things like put the username and password in the log, and you'll be doing that in the projects. So that's the, I learned this from this guy's talk at the security conventions, Dancing with Dalvik. He had a 3-year-old child, and his daughter was playing Android games, and they were too hard. He said, how hard would it be to make this game easier? And he said, hey, this is actually incredibly easy. You can just open the game, change the speed of the bad guys, and you can totally modify an Android app. You don't need anything complicated at all. And I was very inspired by that. I said, well, I could probably do that to real apps like banking apps and stuff, and what would happen? And the answer is, it's all good, clean fun. So my machine appears to have frozen up. Neat. There's something's happening, and I seem to be totally helpless. My mouse is gone. All right, now something's moving. Aha, and there's a possibility of getting to this chat message. Aha, somebody has a chat message, but I'm not able to get out of the, my Mac is crashing. How rude. There, okay, a chat message. Will you hand out ad code later today? Yes, yeah, after the lecture, I'll have the ad codes. And, good, I finally got my mouse back. Life is good, okay. All right, such is life. Anyway, so we'll do this in detail. I went and got the Bank of America app. I totally brought it down, and I told the Bank of America, and they didn't say anything, except they security officer came and secretly met me at B-Sides and said, you got to quit bad-mouthing the Bank of America. And I said, well, I didn't think you guys even saw anything I told you. He said, oh, we see it all. We argue about it. What's wrong with you anyway? I said, well, you're going to fix it? And he said, no. I said, well, you know, then we still have a problem here. Because this is M10, most people just don't care. They don't, because see, this is very much like cross-site scripting. They didn't explain it to me, but this is my interpretation. If I make an app and I don't correctly protect it, so someone can modify it, someone can make a fake Bank of America app and trick people into installing it and then steal their passwords. But that is not the Bank of America's problem. They're not committing a crime. They're not responsible for that. This is, for example, until about 5 or 6 years ago, all the banks did not really use HTTPS. They had a site that was HTTP, and they had a button that was HTTPS to log in. And that means you could totally copy the whole web page, make a fake one. It would look exactly the same with a fake button and steal your credit card numbers. And it happened all the time, phishing scams, but the banks were not legally liable for that. Their site didn't commit the crime. Making a site that was easily duplicated was not considered their responsibility. And I think it's the same here. From a legal financial point of view, I don't think they care. But, you know, there will come a time when things change, perhaps. Anyway, so Bank of America, you can totally go in here and modify it. I put in evil Trojan code to steal the credit card numbers out of the bank app. And now when you put it on the modified app, it totally puts your credit card numbers in a log where they can be easily stolen. So I did this to a lot of other banks, Capital One, SunTrust, and a bunch of other things. And Google does not clean the store either. There's a ton of malware in the Google App Store. They're extremely ineffective. They have this thing they run called Guard Dog or something that totally doesn't work. So there's tons of malware in the store. Thousands and thousands of people have downloaded things. By the way, there's a product you can buy called -O that really protects your app. It changes everything to names like this, and all the variable names change to things like that. Now, that would slow me down. I can no longer grep for the password and find it. You could still do it. I wrote a script that will do it. You can write a Python script that will print out every variable, all the millions of them, so your app runs dog slow, and somewhere in there is your password. And you could eventually figure out which one of these horrible things is the password, but it does slow you down. That would make it pretty painful, sort of like compiled Windows code, to where most people are just going to give up and find another way to steal your money rather than dig through all that. Anyway, so there's the OWASP top 10 risks. We're going to go through this more. There are many other things to go wrong, like using poor cryptography and not encrypting stuff on the network. And the one I just mentioned is lack of binary protections, the 10th one. That's the one that almost every app is vulnerable to. Anyway, then there's broken SSL is a big one. It turns out many Android apps do not actually use HTTPS. They use it, but they do not verify the certificate. So you can do a man-in-the-middle attack with a fake certificate, and they don't detect that and cheerfully encrypt data with the wrong key. Now, again, the reason why this happens so often is because it's not broken. The average user can use it and log into the website, and it works. So people don't notice or care. It's technically insecure, but the end user has no way to know that. And the company doesn't see anything wrong typically because customers are using it without a problem. It's vulnerable, but it's not, again, it doesn't raise any red flags. And I found that a bunch of them are still vulnerable. Even a bunch of medical apps are still vulnerable, even though they've been told by CERT years ago about it. So I went through a lot of these and found many websites that were vulnerable, and a lot of medical websites that were leaking medical data, and you'll be doing some of them in the homework. So I should, let's see what the other chat is. Does static analysis work on native C code? I would think there it would be more painful. I have not tried it. This is a very good question. There is some native C code on Android, and I would think you would have the more difficult kind of static analysis there. I'm not sure, though. It's a good question. Anyway, so I just want to point out, when I first taught this class, I used a fake app that was insecure, so we could practice seeing all the vulnerabilities, and then I tested real apps. So we're using real apps in this class. Almost all these are real apps, and people have been notified and they just don't care. So we're using Safeway and GENYMOTION, a medical app, Ask a Lawyer, the #1 lawyer app. And these guys, I've been told years ago about the problem. They don't care until they become homework. Anyway, so let me just talk a little bit about cryptography, and then I just want to demonstrate the latest attack here, and that'll be enough, I think, for today. So I gave this talk a while ago at a couple of conferences. So like I said before, you have to remember who somebody is. Now, how would you do that? Well, the right way to do it is the way Target does it. Target is a good example here. Not everybody is evil on Android, just most of them. So This is the right way to do it. Target Australia is the one I found convenient to analyze. So you install the Target Australia app, and then you log in. And when you log in, it sends your username and password up to the server, and it sends it over HTTPS. And in fact, it correctly implements HTTPS. So if you man in the middle, which I did here with Burp, it will warn you, this looks bad and you have to install a trusted Burp certificate, and then it will do it. So it does the right thing. It sends your data up to the server for authentication with encryption, which is what you should do. And then after you send it to the server replies with a cookie, which is just a long random string of junk, and you store the cookie on your phone. This is the right way to do it. This is how almost all web apps work. If you want to remember who somebody is, you don't memorize their username or their password or something stupid. You have this cookie, which means only something to that one app. And if somebody steals the cookie, all they can do is hack into this website, not anybody else. And in fact, if you are even smarter, the cookie contains, in a cryptographic way, information like your IP address or identifier of your phone, so that if you put it on another phone, it won't work. And I don't know if Target did that, but at least they did this. They identify you with a cookie, which is the correct way to do it. And this has been this way for 20 years on the web. I thought this was established dogma, but it is not on Android phones. Android phones are like getting in a time machine and going back to 1993 when people didn't know anything about security. They're doing incredibly stupid things that everybody else learned 20 years ago to stop doing, and they're still doing them. It is very strange, but I think it all comes from the fact that the end user can't see what's going on the phone. So the end users do not know how much they're being hoodwinked into using garbage. So Staples, for example, is bad. I installed the Staples app, and if you look at the local storage, it has this thing called encrypted password just sitting there, base 64. I said, they wouldn't put the password on your phone. That's insane. Nobody would do that. And here's a website talking about this. So never put a password on the phone. What are you, stupid? Passwords are important. The problem with passwords is people reuse passwords. So if you lose somebody's password, you mess up their whole life, not just your one company. So don't store the password. There's no reason for it. Just store a cookie. But if you feel like you have to, there is a thing called Android Keychain, just like the iOS Keychain, which is a secure place to put secrets. If you really feel you have to, it's there. There's an API to use. That's where to put it. If you're not going to do that, you encrypt it with a public key. And the private key is not on the phone. It's on the server. That's another option. But nobody does this. What everybody does is they do this. They either store it in plain text on the phone with no encryption at all, or they store it with a private key, and then they try to hide the private key on the phone, which is incredibly stupid because I can see your source code. You can't hide anything from me. I can see where you put the key. This is really, really dumb. This is like hiding your key under the mat when the mat is transparent. It's amazingly foolish. And this is what almost every app does. So they have this encrypted password. So there are various ways to break the encryption, and we'll go through it in the cryptography class and somewhat here. One cute trick I learned is to use a password that has 32 repeated letters. Yeah. If the cookie gets deleted, then you have to log in with your password again. And that's all. But if the cookie gets stolen, it does not affect your life the way a stolen password does. That's why it's better. Anyway, so now you just have to reverse the encryption, and it turns out you can read the source code and do it. So I can read the Smali code. There's this thing called encrypted password that calls this function, and that function calls this, and here's where it builds the key. It takes the brand of the phone, the device number, the model number, the serial number, and the name of the app, and combines them together. And then it puts extra salt in front of it, and then it runs it through SHA-1 and takes the first 128 bits, and that's the key. So that's their method of hiding the key under the mat, this predictable key. And that might even be relatively secure if I couldn't read your source code and totally see how you did it. But I can. So what was the point of all this nonsense? And so I can totally reverse the key. So I told them, they don't care. Then I made a video of doing it on YouTube, and they didn't care. And then I gave my students homework to steal the credit card number out of my Staples account, and they didn't care. And after about a year, they finally put a very thin patch on it. They made it so you can't run this on a rooted device, which makes it a little harder to do this. I haven't bothered to check and see if they actually fixed the problem. I think they probably didn't. This is a fairly common arrangement. You see this a lot. We have patched the vulnerability you reported. This is usually what people do. And then they sent me a letter from their lawyer saying, you're not allowed to reverse engineer our app. I said, what do you mean? They said, did you read the terms of service? I said, well, actually, I didn't. When you open the terms of service, it says in screaming letters, you cannot reverse engineer this app. You're not allowed to look at it. Absolutely not. So I asked my lawyer, and he said, they can't say that. They can't tell you you're not allowed to test the app for security before you use it. That is fair use. So I didn't take any of that stuff down, and they didn't lock me in jail yet. So yeah.
So how, whenever you use an app, isn't there like a section you have to say, I agree to the terms and conditions?
I don't remember saying I agree, but I think even if you do, you can't give away your rights.
Or like, is it implied? Is it implicit if you use an app that agrees to the terms of service?
They like to say so. I mean, they often make a legal claim of stuff they really can't prove. And then there's, I mean, this is why you need a lawyer. People claim to have all these rights, and then there's what you do this, and you need a lawyer to guide you through it. I tried to be absolutely legal all the time for years until I discovered a bunch of what I was doing was illegal, and now I've kind of accepted I'm the same as everybody else. I'm doing stuff which is technically illegal sometimes, and you have to understand where the line is. This is not where I wanted to be, but that's where you end up in this business. And when I went to B-Sides, we met with representatives of the FBI and the Department of Justice, and they said, we are aware that everything you guys do is illegal, but you can trust us. We only prosecute the bad guys. The good guys are okay. And I'm like, well, I was sort of hoping for a more secure foundation for my business than that. But the fact is, that is where we are. So I try to be very public about what I do and present it, make it clear I'm a good guy. And so far, they haven't locked me up. And I don't actually steal money or anything, but I do test apps, and I violate the terms of service and stuff like that. And so anyway, so these guys, you have plaintext password storage. These guys have plaintext logins over the network. These guys have broken SSL. I was real excited when I found this one, but it's not an Amazon product. It's some third-party product. You hunt for prices on Amazon, but it does leak your Amazon password, which is kind of a drag. But it's not an Amazon product. So it's, you know, Amazon is pretty smart. Amazon and Microsoft, for example, are pretty smart. They're really serious about security these days. And Apple, you know, you're not going to find huge problems like this on their apps, not for long. And they'll actually patch them. But there's a bunch of third-party people putting junk in here. Anyway, so let me just talk about the new one, which is this one right here. This is a 0-day that came out today, ES Explorer. Let me show you the joy of ES Explorer. So we're going to do a lot of Android projects in here, and for this one, we're going to use the system. For most of the projects, it's going to take you 3 or 4 projects to get this all set up on your machine, but this is how it mostly works. We're going to use Kali Linux as the attacker, just like we do in almost all my classes. Most American pen testers use Kali Linux because it makes it easy to do almost any attack, and it includes Android attacks in addition to everything else. And we're going to use GENYMOTION as the target. GENYMOTION is a very nice free Android emulator. So you can now real developers get a pile of real Android phones to make sure everything is just right, but we're cheap. And this is a way to get a free simulated phone. It is not perfect, by the way. It does crash now and then, and you have to restart it, and it kind of runs slow, but it is good enough to test things. And so I'm going to get my Android phone, Google Pixel 3 up here, which is running the latest version of Android. Last time I taught this class, we used Android 4, and now I've updated to Android 9, and nothing is different. All the old stuff still works. Anyway, so you can swipe up here. That isn't working very well for me, so I use this little button on the side. Seems to work better. And then I put in my top secret PIN of 1234. And now I'm in. And here's my phone. I've been testing various apps on here. And for this one, I want to use ES File Explorer, which I'm not seeing there, but you can see all the apps by swiping up from the bottom. Then you get to all apps. And this is the thing, ES File Explorer is something very many people put on their phone. And what it does is it lets you see what's on your phone, your movies, your images and such, and wander through them. But there is not a File Explorer, for some reason, included in Android by default. Like the reason Microsoft, there is File Explorer. So you can see your folders. It's not in Android by default. You have to add it. And this is mostly what people put on, 100 million downloads. It's really popular. I've used it before. It's very common. What I did not know is that this is not only letting you browse your files, it's handing them out to everybody. And it's been that way for years. So that's interesting. And so let's play with it. If I go here, let me exit that and make this bigger. Okay, this is my Kali machine controlled by SSH, and let me make my font bigger and try and put it up higher on the screen. Okay, so now if I think I'll go up here, and what I want to do is do ADB connect. Should be up here in my, there, ADB connect. This is the IP address of my simulated phone. I connect with ADB. Now I'm connected, so I can do devices list. devices minus L. Got to spell it better though. And so there's my phone. It is a Google V-Box. It is an actual x86 phone. It is not running ARM. ARM is the processor on real phones. This x86 emulator is running x86 code, but it has an ARM translator, so it can run ARM apps. Anyway, so this is my phone. It's listening on that IP address on port 5555, and I turned on USB debugging, which goes over the network so I can control the phone from here. So I can do ADB shell. And now I get a command line on the phone. This is the Android operating system I'm looking at here. And you'll play with this quite a bit in the projects, but the Android is very much like Ubuntu Linux. If I go to, say, the root, and then I do ls-p, I can see that this has all the usual stuff like etch and dev and sbin and root, the same stuff you're used to seeing on any Android system. And it has a thing called data, which is where the data for apps is stored. And a lot of typical Linux commands work here. And the one of interest to us right now is netstat minus pant. This is running on Android. If you do that, you get a lot of lines about network traffic. And if you filter it to look for the listening ports with grep, which works just the same, then you can see the listening ports. And right here is something listening on port 597077. And that is estrongs.android.pop. That is ES File Explorer. It is supposed to be showing me the files so I can browse around the files on my phone. And for some reason, it's listening on a network port, which is kind of disturbing. And it gets more disturbing because it is, in fact, letting you issue commands over that port with no authentication. And it's serving all the files over that port with no authentication. It's like an open FTP server. And it appears to have been this way for years, and it wasn't until earlier today that somebody noticed. So let me shrink this down to get down to the good here. Here we are. So if I, so here, let's go all the way. So if I take a picture on my phone, let's do this live. This is good, clean fun. You can take pictures on your simulated phone. Here's the camera. You can connect it to your real camera, is what I'm going to do. Webcam 0 and webcam 0. Okay. Now it's connected to my real camera. It looks like my phone crashed and restarted, but that's all right. I don't care. Now I can log in again. Okay, so now I can take pictures with my camera. I open all my apps. I go to the camera. Okay. And now, yes, the camera works. And if I don't want it sideways, there's even a thing someplace to rotate it. I may not be able to find it. It's one of these things. I did it before. Well, I'll settle for this one since there is a way to rotate it, but I'm not finding it right now, and I don't care. So I'm going to take that picture. Okay. So now I've taken a picture, and the picture is, of course, on the phone someplace. Now, the idea, everybody imagines, is that the picture is on their phone and it doesn't go to someone else unless I email it to them or something, but that is most emphatically not true. So if we just go here, right there's the command, all you have to do is send a curl command to the phone, which is just a web request. And in the curl command, there's a list of like 10 commands, and one of them is list pics, which does just what you think it's going to do. And this is not on the Android file system. It's on anyone on the network, anybody in the coffee house where you take your phone. So I connect, issue the list pics command, and there are all the pics on my phone. Here's various ones I've taken. Now I'll be able to tell from the time. Here's the one I took earlier at 2 p.m. when I wrote the project. Here's the one at 9 p.m. I guess my phone is on Eastern Standard Time or something. Anyway, this is the image I want to get. And that image is at this location, storage, all this jazz going down to a JPEG. And all I have to do is wget it. So I'm going to paste that in and then put in the wget, the IP address. All I need is the most obvious thing. I go to the IP address of the phone and that port. It is serving a web server on that port that serves out all your files. Yeah.
I'm assuming this also applies to emails that are stored on your phone.
It's a good question, and I do not know. It'd be fun to play with it. It's just brand new. I've only known this for a couple hours. I don't know how far it goes. Yeah, it's a very good question, and I do not know how far it goes. I don't know if you can get every file off the phone, but you can get a lot. And really, getting the images is about all by itself enough to make a lot of people worried. Anyway, so now I should be able to get that image off the phone by just putting wget at the start of this line. And right there, that should do it. Yep, I just downloaded something. And now to open it, I can open it on my desktop. It's right in my root here, but I need to go to my graphic environment, which is here. If I do, okay, there's the, okay, I'm losing my mind. Where's the image? Let's see where this is. PWD, it's in root, okay. PWD, I say. Well, that's rude. Oh, there it is, image.jpg. Okay, good. So I can open it here, and I put in here the command line command to do that because I just got used to using the command line. Let's get this junk off the screen if possible. All right, will not go away. This is very common. This stinking thing doesn't work very well. All right, keep on irritating me. See how much I love it. Now there's no handle. Okay, go away. Thank you. All right, so it is XDG open. There we are. Oops. And now this, I put it in the wrong window. There's no graphics in that window. Got to do it here. XDG. If I can type XDG-open the image. There. There you are. And there's the glorious image. So that's the point. And that anybody on the local network can just totally take it. No login, no hack, no nothing. And they told the people that made this product, and they didn't patch it, and they got a CVE number, and they say it only listed being vulnerable up to like 2 versions back. So I actually tracked down an old version, but the latest version works just fine. So anyway, this is the way many homeworks are going to be in this class. We're going to use the latest version of real commercial apps that should have been patched. And so I've learned to always put an old version here. If they ever do patch this, and I think they might eventually get humiliated into caring, then I have the old version here. So you can download and do your homework, even if these people finally wake up. But many times it takes years. This one I think is hitting the press and people are pretty excited. This one I think affects a lot of real users in a way they can easily understand. I think they're probably going to have to really patch this. That's a very good question. How can you protect yourself? Simplest thing is don't use this app. Use another app. But the other thing, you could put a firewall on your phone, I guess. There are security products like McAfee and Norton and Blue Box for Android, and I guess maybe they have firewalls. It's a good question. Yeah.
Just going through the code and disable it from this.
Oh, sure. You could patch it yourself by modifying the code, and in fact, that's not that hard. And if you do the homework projects, you'll see. But I mean, realistically, I'd say installing a security product of some kind would probably help. There are security products. There's antivirus suites for Android, and I guess they probably include firewalls. So maybe that would help. You kind of need that. Like Windows, it is so vulnerable. You do need another layer of security. So that's a very good point. And that would make a good project. I should find out what security solutions actually help. I do not know. Does anybody have experience with Android antivirus in here and how well they work? Which one's good? I know they exist, and I know you really need to use them if you use an Android phone because it has a lot of problems like this, but I don't really know exactly what security they provide. And that's a very good point. And by the way, I mentioned you do not have to do these homeworks I give you. You can do your own stuff. So if any of you would like to research, for example, antivirus and firewalls for the phone, that would be fine. You can present it to the class or just write it up and I'll give you points for it. There's many things to do here that are important, and I'm just putting some of them here. But if you have something interesting to do, feel free to do it. Oh, there's one more thing I should mention in that spirit. There's a Saturday morning class that Elizabeth is going to teach here, but in the afternoons, we are going to do red versus blue, which we did last semester. And this is worth extra credit, and I highly recommend it. Let me see if I can figure out where the page went. Okay. So starting here on the 31st, in the afternoon, we're going to do red versus blue, which is head-to-head competition. We did 3 versions of it last semester, and it's getting better. I'm going to be doing this through the semester. I'm going to be trying to make videos so people can watch it and see what's going on. And by the end of the semester, I'm going to have real competition with other colleges. This is intended to be a simple 1 or 2 hour event with small teams, one-on-one, a team of 2 defending and a team of 2 attacking is what I'm planning for. And I think it's a really good way to teach people, and I'm going to polish it up here. I'm going to be doing it at all the conventions. I'm going to be doing it in Indiana and Illinois and DEF CON and everywhere. And many colleges want to get in on this. So it's worth extra credit, and I highly encourage you coming to do it. There's also the big competition, CCDC and CPTC, which Liz is organizing in this class. And but that's, you know, that's pretty advanced. And there's a small team, and they have to be full-time students, and it's pretty annoying. This red versus blue, there are no requirements. It can just be anybody. You don't have to jump through any hoops to get in, because I'm sort of allergic to all that. That's why I decided to make my own with no rules, because the one with rules is too annoying. So anyway, I encourage you to come check this out if you like. It's worth extra credit, and it ought to be fun. And there's a job fair. I put it up there, but many people came in later. There's a job fair next Tuesday. We're not quite sure who's coming yet, but we're going to have a lot of students there with resumes and some employers to hire them. So if you are interested in getting a job, you should come. Even if you are not ready to get a job yet, you could listen and find out what people are looking for. It's very good to get practice. So I'll bring up the ad codes pretty soon. Are there any questions out there? Right.
Where's the location of red versus blue in here?
In here. It'll be in here and at 1 p.m. And it's only occasionally, because I am teaching a 1-unit course at that time, so I put it in between the meetings out of the course. But there's enough for like 8 sessions of this. It should be good. Yeah. Yeah, she'll be teaching 124 in the morning.
Is she also an upload the message to YouTube?
I think she is, yes. And even if she doesn't, my 124 from previous semester is up there. So yeah, but I think she'll be streaming it and putting it on YouTube, I think. But we'll know for sure this Saturday. Because I think it's the same. People really like to be able to remotely connect and view it later. I think that's fine. So
what's the percentage wise? So you do the CTF and 124, so that's just going to be all extra credit? Or?
Well, this red versus blue is outside all the classes, so it's extra credit for any class. And I think I'll make it like 20 or 30 points every time you do it. That's all. Good. And oh, the other thing, there's something else I told you about the job fair. I guess I've told you everything I need to tell you. Is there anybody in the Zoom that wants an ad code? Let's see, ESET. Yeah, ESET. I'm not sure what this is about. Anyway, all right. ESET is a Microsoft tool to secure things, I know. Anyway, ESET's an antivirus for Android. Oh, that's a good point. Yeah, ESET is one of the antivirus vendors. They might have a good one. That's a good point. I do not, actually, I'm glad you asked that question. This is an obvious problem many people have now. It's interesting to know if there's something you could install that would stop this problem right now. That would be a good thing to have. Yeah.
Sophos seems to have a,
what's that?
Sophos.
Yeah, Sophos.
Seems to have like a nice feature.
Good.
Antivirus for the phone.
Yes, I mean, actually, I'd add that to the project. For extra credit, put on some antivirus and see if it blocks it. Because they're free. That would be perfectly fine. Now that you've got the attack going, we should explore the defenses. That's a very good question. Let's see if there's another thing coming up here. ESET antivirus is free. Yeah, ESET is free, a bunch of free ones. So yeah, check them out. I would like to know if they work. And I'm sure there is some kind of firewall you can put on that would save you. I'm sure you could put on IP tables or something, but there's probably something easier. Yeah. Well, the firewall is the part that I think would stop this problem, but maybe security solution of some sort. There may be something else. I think McAfee and Norton have them, Android versions. Oh, okay. I know Blue Box does. Blue Box was the first, and they're pretty advanced. So there are a bunch of security solutions to add to your Android, and you really need it because Android is so vulnerable. So this is actually a very interesting topic and not what I thought of, because my natural inclination is on the red team, but the blue team stuff for Android is in fact very important. All right, I'm going to bring up the ad codes, see if anybody needs those, and then I'll just go up and see if anybody wants to work in the lab today, but nothing's due for a couple of weeks. Here's the ad codes. So people that need ad codes for this class, this is 128, and they're somewhere on my list. Well, I thought, there we are, there's 128. Good. All right. So does anybody need an ad code? Oh, okay, Dale, good. So there's one. It's 4ZTIHY. Yeah. Anybody else? Yeah, okay. Maribel. All right. So there you go. 573I24, I think. If I send you one by email, it should be as good as anything. which is not all that good, but it's as good as one of these. Yeah, you need one. Okay. Sarah. All right. There you go. 5I695E. Maybe that's a 1. I can't tell if it's a 1 or a 9. Oh, it's an I. The 1 has a little tail on it.
Yeah.
Okay. Anybody else?
I guess I'll take one.
Okay. All right. There you go. 62D for H1. Yeah. Yeah. Okay. And anyway, you can get them later. You've got a couple weeks to add, but you might as well start early because you're going to have to struggle with the ad system. All right. Well, I'll stop the share. There's another Zoom chat. Let's see if someone needs an ad code here. Need an ad code. Okay. Okay. K wants one. All right. There you go. I will move this so we can see it there. So it's 6VWCDO. Good. Anybody else? Oh, K. Okay. Just one guy. Good. Okay. And I'm going to stop the share and I'll clean up and go up to the lab and hang out there for a while if people want to work here. Other than that, we'll just do this again next week. And if you want to come in a couple weeks on Saturday, there'll be that red versus blue thing. But the immediate thing is the job fair. I highly recommend if you're looking for a job, come to that.